Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab, a channel specially created for you and I to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today promises to be fun, exciting, and interesting as usual. We continue on our topic, Surds. In our previous videos, we've learned the basic concepts of Surds, the addition, subtraction, and multiplication of Surds. However, today we are taking the last operation of Surds, which is division. To divide Surds, I must emphasize that you need a good understanding of multiplication of Surds, most importantly, and of course, the addition and subtraction. When you talk of division of Surds, it means we are talking about fractions or rational functions. We either have square root as numerator or as the denominator. When we have root as numerator in rational functions, there's no issue whatsoever. But the challenge arises when you have square root as denominator, which is not allowed in mathematics. Hence, the need to rationalize. Rationalize basically means the process of eradicating the square root from the denominator. And we have two categories in this case, as we can see on the examples on the board. So either we have the monomial case or the binomial case. By monomial, I mean we have just a single root value as the denominator, whereas in the binomial, we have the root with other terms. We have two separate terms entirely, separated by either a plus or a minus. So how do all this pan out? That is the essence of today's lesson. So please, sit back and enjoy. For question 1, we have to simplify this. Remember, the aim is to eradicate root. I must quickly point out a common mistake that students make or candidates make in exam is to tend to divide this numerator and denominator. You can't do that, they are not the same. If there had been root and root, then you can go ahead. So don't say 2 goes here 8, 2 goes here 3. That would be wrong. Rather, we go this way by saying 8 over root 6, which is a question anyway. We seek to eradicate this root. We simply multiply numerator and denominator again by the same thing. That's the way to go. Then for numerator, we have 8 root 6 over root 6 times root 6 is simply 6. It's like saying root 6 squared. The square cancels the square root as it were. Again, don't be tempted to say 6 here 1, 6 here 1, because they are not under the same square root. However, we can work with 6 and 8. So I'm going to say 2 in 8, 4, 2 in 6, 3. Then with 6 remains untouched, and that is the end of the solution. Very straightforward. Then B, we got a difference variant, which simply means we have root at the numerator. As I said earlier, we have no problem with the root at the numerator. Our challenge is the denominator. So, similarly, to get rid of this, all we need to do is to simply multiply the numerator and denominator with the value we seek to eradicate, which in this case is root 5. We don't have to include the 2. It's root 5 that we don't want to seek. So, in this case, we're going to expand the numerator because we have a bracket and multiply the denominator. So here we have 3 root 2 times root 5. Remember the laws of Surds, that's root 2 times root 5 is root 10. Then minus 4 times root 5 is minus 4 root 5. And that's the numerator. For denominator, I'm going to have 2 times root 5 times root 5 is simply 5. Hence, our solution becomes 3 root 10 minus 4 root 5 over 10. Once again, we've achieved our aim of eradicating the square root. So we have this as a solution. So these are the two ways of solving the case for monomials. So without much hassles, let's now go to the binomials, which seems to be more fun. Now, to help us tackle the case of binomials, we introduce the concept of conjugate source. Conjugate source is best explained by having a surd, a binomial surd, a plus b root c. Its conjugate is simply the additive inverse of the surd, and that means we are changing this to minus. So we have the negative of this. So similarly, a minus b root c has its conjugate as a plus b root c. Simply put, just change the sign in between, and that is the conjugate, vice versa. So we are using this concept in solving questions C and D. As you can see, we can't expect to solve C and D in pretty much the same way as A and B, because that's binomial. So we have 8 over 3 plus 4 root 2. Again, we are using the denominator to determine what the conjugate is. In this case, it is what? 3 plus 4 root 2. What's the conjugate? It should be 3 minus 4 root 2. So, the conjugate of 3 plus 4 root 2 is 3 minus 4 root 2, which must maintain for both numerator and denominator. Then we multiply the numerators and denominator separately. So 8 times 3 there is 24. 8 times minus 4 is minus 32. Root 2. Now if you look at this conjugate multiplication, it brings to mind the concept of a difference of two squares in your elementary algebra. So if you have n squared minus n squared, it simply means n plus n times n minus n, and vice versa. So this time around, we are working backwards now. So this is like saying m, this is n. So m plus n, m minus n. That simply means m, which is 3 squared, minus n squared. So the m is 3, and 4 root 2 is n. So we have what here? 24 minus 32 root 2 over 3 squared is 9, minus 4 squared is 16, and 2 squared is just 2. Hence we have 24 minus 32 root 2 over, so we have 9 minus 32. Hence we have 24 minus 32 root 2 over minus 23. And that is the end of the solution to that particular problem, which I believe you found quite interesting. Without wasting much time, let's go to the last one, which is question B. And it's pretty much going to be patterned according to C. So, we have 2 root 3 plus 3 root 2 over 2 root 3 minus 2 root 2. Again, our conjugate will determine, our denominator will determine our conjugate. So we have 2 root 3 plus 3 root 2 over 2 root 3 minus 2 root 2. That's the denominator. So the conjugate will be simply 2 root 3 plus 2 root 2 over 2 root 3 plus 2 root 2 again. So now we have a whole expansion to do here, both numerator and denominator. So carefully, we look at this step by step. So we go 2 by 2, 4. Root 3 by root 3, 3. That's the first. Then again, 2 by 2, 4. Root 3 by root 2, root 6. Look at that. I'm taking these two and multiplying both brackets, both contents in the bracket. Once I'm done with that, I come to 3 root 2. So I'm going to have 3 times 2, 6. Root 2 times root 3, root 6. Similarly, 3 by 2, 6. And root 2 times root 2, simply 2. And like the previous example, we have conjugates here, multiplying themselves. Using the concept of difference of two squares, I'm going to have 2 root 3 all squared minus 2 root 2 all squared. Then we have 4 times 3 here is 12. Then likewise 6 times 2 there is also 12. They are like terms. Let's bring them together because they have no roots. Then we have 4 root 6 plus 6 root 6 over. Now 2 squared there is 4. Root 3 squared is 3. Minus 2 squared is 4. Root 2 square is 2. So we have here now 12 plus 12 is 24 plus 4 plus 6 is 10 root 6 over, this is 12 here, minus this is 8. So we are left with 24 plus 10 root 6 over 4. And that is the end of the solution to question D, which I believe you found quite interesting and fun. So in summary, today we have looked at division of surds. And by dividing surds, our aim basically is to eradicate the square root from the denominator. And the process of doing this is called rationalization. And we can have two categories, either the monomial denominators or the binomial denominators. So the first two examples were meant to explain how to go by monomial denominator solution. Whereas the second one is by the binomial, where we use the concept of conjugate surds. I believe you found it quite interesting, as I said earlier on. If you do, please feel free to share, subscribe, like, comment. Let's hear your feedback to know how best we can make the videos better. Thank you and God bless.